Explanation and examples under section 2.3 Introduction to Linear Polynomials. Section 2.3 Exploring Linear Patterns. If you look into the figure given, it represents a set of stages, each stage having a set of tiles. So stage 1 has 1 tile, 2 has 3, 3 has 5, 4 has 7, 5 has 9, 6 has 11, 7 has 13. So what we are asked to find is to predict the number of squares in the next 3 stages of the pattern and write the sequence up to the stage 7 of the pattern. So it is the same as what is given in the tabular column. How do we go by the number of tiles in each pattern? It is just, as you can see from the numbers, it is just an incremental by 2 as each and every stage increases by 1. So each stage is obtained by adding 2 more tiles to the previous stage. So this table mentions the number of tiles for the first 7 stages. So manually, if you look into stage 7, you can very well find out, you can count and say that it has 13 tiles. But how do we generalize this pattern? Say you want to find 101st stage. To find the number of square tiles in that stage, we cannot go about step-by-step approach like incrementing each and every step and incrementing the number of tiles by 2. So we should make use of the linear pattern to obtain this kind of answers. So to generalize this pattern, we observe that the number of squares at each stage is 1 less than twice the number of the term. So say for example, you choose stage 4. What is given is if you make twice the number of terms, so 4 times 2 is 8, but the number of square tiles is 1 less than 8. Say for example, we can choose stage number 7. Twice of number 7 is 14, 1 less than 14 is 13, which is the number of square tiles under stage 7. So the number of squares under stage 5 is 2 times 5 minus 1, which is 9, and so on. This leads us to conclude that the number of squares at stage n is given by 2n minus 1. This is a generalized pattern. So you can use this particular linear relationship to find out the number of squares at any stage. So it happens to be very simple. Otherwise, manually, we have to increment each and every stage, the number of tiles by 2, which is a very tedious process. To simplify this kind of tedious processes, we make use of this linear relationship. The polynomial 2n minus 1 has a degree of 1. Hence, it is an example of linear polynomial. So we need to refresh what is a linear polynomial. If it has a degree of 1, it's a linear polynomial. If it is 2, it's quadratic, 3 is cubic. So it is a linear polynomial. The degree is 1. What is degree? It is the highest power or the highest exponent in the expression. Also the difference between, so we need to find two interesting facts as far as this linear pattern goes. One is a generalized pattern or a generalized linear relationship which can find out the value at any particular stage, as well as if you see the difference between the consecutive terms, it is 2. The sequence is what? The sequence is the list of values that is derived. So the sequence is 1, 3, 5, 7, 9, 11 and so on. If you see the difference is always constant. What is a constant value? It is 2 for this particular linear relationship. Thus, with each stage, the number of squares increases by 2. The relationship between the stage and the number of square tiles is a linear relationship. You have to understand the definition of this linear relationship. What do we mean by that? That there is a relationship between the number of stages, that is, the first row mentioned in the tabular column, like numbers 1, 2, 3, 4, 5, 6 and so on. This is the number of the stage and the value or the number of square tiles. So 5 and 9 is in a relationship as well as 7 and 11, where the linear relationship has the same root. This is what we call as a linear relationship. Using the expression 2n minus 1, can you find how many tiles will there be? The 15th stage and the 26th stage of the pattern. So there are two questions. Let's look into the first question and the 15th and the 26th stage. So just replace the value of n as 15 and 26 and find out the number of tiles under 15 and 26 stage. It's very simple. Also, which stage will come for 21 tiles and 47? This is a little bit a twisted question. Kind of the value is already given. That is the second row of the tabular column is already given. You are asked to find out the value of n. So, just a simple algebraic equation and then you find the value of n. So if it is 21 tiles, n is 10. If it is 47, n is equal to 23. Example 7. Bella has 100 rupees for pocket money. She spends 5 rupees every day. After how many days will she be left with? 40. So a simple tabular column for in 0 days, that is before the day 1, she is given 100 rupees and at the end of the first day she would have spent 5 rupees, so the remaining she'll be left with 95. Day 2 she'll be left with 90, day 3 85, day 4 is 80. Observe that the amount left on the nth day will be 100 minus 5 n rupees. Therefore, on the 12th day, the amount left will be, just replace the value of n with 12 to find out the number of the amount which is left after 12 days in case she is spending 5 rupees per day out of the pocket money initial amount which is 100 rupees. It happens to be 40 rupees. What amount will be left on the 15th day? There are two questions. Let's look into the first question. So, in the place of Bela, just assume that yourself are given 100 rupees as your pocket money and you're expected to spend around 5 rupees every day. Now, an interesting fact here is you should know at the end of 15th day how much money I will be left with. So, we cannot do a manual calculation 5 rupees, 5 rupees. So, at the end of third day, it's 15. So fourth day it's like 5 more and then do a manual calculation. Instead, we should appreciate the usage of linear relationship to find the amount of money which is left after 15. How do we go about this particular question? The linear expression is 100 minus 5n. If you, how did you come to this 100 minus 5n? The first four values will show you that this particular linear relationship, it follows a pattern. Okay, and so you deduce that the linear expression is 100 minus 5n. So at the end of 15th day, the amount left will be 25 rupees. Just replace the values. So the second question will be, how many days will it take for the entire amount to be spent? Suppose you are given 100 rupees, you are spending 5 rupee per day. You need to find out when my pocket money will get exhausted. So what you will do, you just substitute 100 minus 5n or equate this particular expression to the value of 0 because the value which is left out is 0. So just equate 100 minus 5n to be equal to 0. Find out the value of n, it is 20 days. So at the end of 20 days, you would have exhausted out of your 100 rupees. An interesting fact here is that as the days goes by, the value decreases. In the previous example, we have seen the number of tiles increasing as the stage increases. So, in a linear relationship, the between each and every stage, the value can increase or it can decrease. If it increases, you will call it as linear growth or a linear decay otherwise, which we will see in the subsequent chapters. So as of now, just try to identify that it can increase or decrease in a linear relationship. Fine. So, what are the interesting facts in a linear relationship? There should be a relation between the number of stage and the value obtained after the linear relationship. Point number 1. Point number 2. The difference between the values of the two consecutive stages should be the same. That it should be a constant. If it increases by 2 tiles between the third and the fourth, between the fifth and the sixth also, there should be a difference of 2. Fine. So these two important factors you should understand in a linear relationship. And one more fact about linear relationship after understanding this particular example and the previous example is that it can be go in an increasing order or in a decreasing order as well. Now let's look into example 8. An auto rickshaw fare starts at 25 rupees and remains the same for the initial 2 kilometers. Then it increases by 15 rupees per kilometer. What will be the fare for a total of 10 kilometers? So for the initial 2 kilometers, the fare is 25. So first kilometer is 25. You go for one more kilometer, making it 2 kilometers till you reach 2 kilometers is 25 only. Now, when you reach 3 kilometers, there is an extra kilometer. You have to pay 15 rupees more. So the amount becomes 40. When you go travel for 4 kilometers, once again it increases by 15 rupees, making it 55 rupees to be at the end of 4 kilometers. Now, observe that the total fare for a travel of n kilometers will be, now we are going to replace this specific numbers in terms of a relationship. As how do you do? 25 rupees plus 15 times n minus 2, which is 15n minus 5, based on a condition where n is greater than or equal to 2. Why do we specify this particular condition? Because for the first 2 kilometers, the amount is the same. The linear relationship doesn't apply over here. So it is just a function. So here the fare for the specific distance covered is a function of a distance n, meaning it is, yes, it is dependent on the number of kilometers. The fare is dependent on the number of kilometers, but based on a condition. So these you will not call it as a linear relationship because between the first and the 2, the difference is 0, whereas from 2 till how many ever kilometers you have traveled, between each and every kilometers it increases by 15. But it doesn't satisfy the stages 1 and 2. So you call it as a function where the rate is dependent on the kilometers, provided one more condition is there, n is greater than or equal to 2. So how many kilometers will the fare be? 130. What is 130? It is the value to be equated. You should know where to replace this particular value. If they had asked how many kilometers, they are asking for the number of stage, which is nothing but n. If they have given the value is 130 is given, then it is a value of the you have to pick from the second column. That is, after you apply the linear relationship using a particular stage, what value you will get? That is 130. So based on this, you derive n to be equal to 9 kilometers. Let's try to understand the value of a linear expression and a linear pattern. A linear pattern is nothing but a sequence of numbers where the difference between any two consecutive values is the same. If you look into this particular example, the first linear pattern, the difference is 5, constant throughout. Second pattern has a difference of 2, consistent throughout the sequence. But what is a relationship? Given a particular value of n, if you are able to deduce a value, what it represents at that particular stage, that relationship between the stage number and the value, you call it as a linear relationship. So 2n minus 1 is a linear relationship, 100 minus 5n is a linear relationship.